In this video, I'll show how a rental car agency can use the text mining capabilities inside of SPSS Modeler to improve a predictive model. So in this example, a data scientist at a rental car agency is trying to predict if a customer will continue to use their rental service. The company has basic CRM data for each of its customers, fields like gender and age, for example. The rental agency also has this field called customer status. A customer is classified as active if they've used the rental agency in the last 12 months. The car rental agency wants to build this model so they can store active customers in accordance to their future risk of becoming inactive. By doing this, the car rental company can make retention offers to high-risk customers and improve their future retention rates. Using this data, a data scientist has built the simple tree model shown here. Unfortunately, when this model was evaluated on a testing dataset, it had an area under the curve of 0.65. So this is a relatively poor model and it won't be very useful to the rental agency. The rental agency also has text data in the form of survey responses. In the past, the rental agency has manually read through this data to try to understand themes that were coming out of these satisfaction survey results. However, what they have found is that it takes too long to read through all these surveys manually, and there often aren't any actionable insights they can gain from this process. Text analytics in SPSS Modeler provides a set of linguistic resources such as dictionaries for terms and synonyms, libraries, and templates. The text analytics nodes allow a data scientist to develop and refine these linguistic resources to their context. In the example I'm showing here, the data scientist can take advantage of the customer satisfaction template that comes included in our product. If this company only wanted to determine the most common themes brought up by customers and show that in a distribution chart, we could create a category model and visualize this easily. There's actually a great example of how to do this in the SPSS Modeler documentation that I would recommend. However, for this example, the rental car agency wants to use the text data to improve their predictive model. For this, we'll use the text analytics capabilities to create new features from our text data to use in our model. One quick way to do this is to use text analytics to automatically assign a positive, negative, or neutral sentiment to each survey. Doing sentiment analysis in the text mining node is incredibly easy, as all we need to do is use the sentiments text analytics package. As we can see, the majority of our surveys were labeled with either a positive, negative, or neutral sentiment without us having to do any manual work. This generated model has created new fields in our data, which contain a Boolean value showing the positive or negative sentiment of each survey response. We can then use this as an input into our predictive model. Now I'll create a category model using the pre-installed customer satisfaction text analytics package. This will automatically extract relevant concepts from the data and group them into higher level categories. Running the text mining nodes opens the interactive workbench. This will give us a full view into how this category model is built. In the Concepts tab, I can view the key terms and I can add synonyms and modify the types. This is where the domain knowledge of the data scientist can be really helpful. In this example, I see that we have the concept customer service and we have another concept called service. When I preview the surveys associated with the concept service, I see that these are really similar to the ones shown for customer service. What I can do here is add these two terms as a synonym for one another. We can see here that not all of our concepts were automatically placed into a type. I can manually add any concept that I want to another type. So for example here, we see that company is currently in the type unknown. But what I want to do is add it to the type organization. The Concepts tab of the interactive workbench is a great place to start when you're modifying the pre-shipped templates of text analytics to meet your use case. In the Categories tab, a user can see the categories that came pre-shipped in the text analytics package that they selected. When they build the model, text analytics is actually creating new categories based on the user's data. We can now store the model to see how many documents from our data fit into each category. In this example, we can see that only a small percentage of the documents fall into the uncategorized group. This means we selected a text analytics package that fits our data well. These categories will be used as features in our predictive model. For example, maybe if a customer survey falls into the product quality negative category, they are more likely to not be an active customer. We can preview the documents associated with each category in the preview pane here. If there are any changes you'd like to make, you could go back to the Concepts tab and change your concepts, types, or you could go to the Text Links tab and create new text links, which are oftentimes the foundation of categories. The Resource Editor tab allows for precise control of the libraries used in the text mining process. It's often used by advanced users only and can be used to create and tweak domain-specific synonyms, create new types, create advanced text links, specify words to ignore, or even create new library modules. In most cases, and in this example, the resource editor is unnecessary because the text analytics package that was chosen at the start of the text mining process came pre-trained with a category and concept model that fit the data very well. Once this category model is generated, we can connect it to our data sources and preview how each survey was categorized. We now have the negative and positive sentiment categories that we generated in our first model, along with the categorization that was generated in the model we just created. We can see how each survey falls into one of the following categories. The initial tree model can now be rebuilt with the inclusion of the sentiment analysis and the categorization that were done in the text mining node. In the Model Viewer output, under the Feature Importance tab, we can see that a customer's negative sentiment on a survey is a key indicator of their churn. We also see that service promptness, service knowledge, and a mention of pricing can be key indicators of churn in a customer survey. The tree diagram can be used to visually see how our model makes predictions. However, it's clear right away that this model is much more complex than our initial model. When we analyze this model, we see that the accuracy is much higher than our initial model. Now we have an area under the curve of 0.88 compared to our initial 0.65. The rental car agency could deploy this model and use it to predict the active or inactive status of a different group of customers. And they now understand some of the most important themes to look out for when they receive new survey data. The text analytics capabilities in SPSS Modeler allow anyone to understand themes and improve predictive models using their text data.